All right, Bulldogs, here's what we're going to do. I've got an extra bonus lab for you that I've come up with that we haven't done before in this course. So I know you're going to get a lot out of that, but I want you to see this theory first. So we're not jumping straight into the lab on this video. We're going to go over DLCIs and a couple other important topics and lay the foundation for the first lab, and then we'll jump right in, or the next lab, I should say. Now, we've got to have some kind of address for our frame relay VCs, and in this case, with the frame relay VC, we use DLCIs, a data link connection identifier. And it's a frame relay layer 2 address. But it's unlike, say, a MAC address because it can be reused from one router to another in the same network. Now, you wouldn't want to do that with a MAC address, and you wouldn't want to do it with an IP address. But you can do it with DLCIs. They are locally significant only. They're not advertised actively to other routers. Now that sounds kind of odd. Oh, I've got this address I can use multiple places, but all of this theory will become even clearer for you after we go through some labs, both dynamic and static. And that's one thing I want to show you here on the board in a moment. But here's a point I want to hit with you right now. You know that I am all for letting the routers and switches do the work dynamically whenever possible, because it saves our time, and usually the dynamic method is much more effective than the static method. And it doesn't matter which layer you're at, that's almost always true. We also know, or do know now, that without the right frame mappings, the rest of our frame relay work is totally useless. That's the core of everything we do. We have to have a DLCI to IP address mapping. If we don't have that, the rest of the frame network is just not going to work. And if you don't have layer 2 working, I guarantee a layer 3 that we're putting on top of it basically is not going to work either. Layer 2 is the foundation for layer 3. We got to get layer 2 right before we can even start with our routing protocols. Now, for those map statements, we have two options. Inverse ARP, which is the protocol that enables dynamic mappings, and static frame map statements, which naturally you and I as the network admins have to write. Now, I'm going to show you the network, and we're going to come back to this too, because I want to keep the discussion rolling here. We're going to use DLCIs 122 and 123 on router 1, DLCI 221 on router 2, and DLCI 321 on router 3. Let's talk about inverse ARP, though, before we actually head for the lab. And I want to show you an odd result you can get on live equipment from time to time. Inverse ARP, it's enabled by default on a Cisco interface running frame relay. You enter the incap frame command, you open the interface, bam, you're running inverse ARP. Now, what is supposed to happen next is the router sends an inverse ARP packet announcing its IP address. The receiving router gets the packet, creates a DLCI, local DLCI to remote IP address mapping, and the receiving router then puts that in its frame relay mapping table, which we will see live shortly, and then entry will be marked dynamic. Now, that's fantastic if it works. That is the theory. Inverse ARP can be quirky, to say the least. It can be tough to work with. It works in some large networks, I know, perfectly fine. But a long time ago, certain network admins, and it's pretty much me included, chose a long time ago, look, when I'm working with frame relay, I'm going to do the map statements statically because I put them in there once and I never have to worry about them again. Nothing against inverse ARP again, it's just a very good idea for the exam and the real world for you to be fluent in both of these, if you will. Well, with inverse ARP, you don't really have to know anything except how to open an interface. Really, that's all you're doing. Incap frame, open the interface, you're done. But you really need to learn static map statements and their syntax for the exam and the real world. And we are definitely going to be diving into that very shortly. So I've got a config here, and this is actually what I wanted to show you. And again, we're going to be doing all this live here in a moment, so don't think I'm skipping over anything here because I'm not. But here I opened an interface, line protocol came up, everything worked fine, and then I ran a command called show frame map, short of course for show frame relay mappings. And I got these mappings with an IP address of all zeros. And I got one for actually two of them there. And what happens is this mapping to 0000, it occasionally happens with inverse ARP. These mappings don't really hurt anything unless you've got a proctor who really wants you to get rid of them in the IE lab. So if you want to leave them there, I've seen them on routers before, production routers. They don't really hurt anything. The only way that I personally have ever seen to get rid of them is to disable inverse ARP and then reload the router. Because if you do no frame inverse ARP on an interface, which we'll do live here, actually I'll show you that here. Turn inverse ARP off with the no frame relay inverse ARP command. If you run that command after the mappings with the zeros are in there, they're not going to come out. Again, they don't really hurt anything, and the only way to get rid of them I've ever seen is with disabling it and then reloading the router. Okay? If you decide to turn it back on, it will not surprise you to know the command is frame inverse ARP, and that's it. And there is a little hyphen in there we got to watch. Before we get to this, I'm going to give you my famous DLC lecture, and some of you who have taken my course before are like, oh no, here he goes. But this is so important because we got to be able to write successful frame map statements. You always map the local DLC to the remote IP address, because I see them in practice exams, and it wouldn't surprise me if the exam had a question like that. You know, they could show you 7 frame map statements all next to each other on the screen and say, which ones of these are right. And you can eliminate some immediately if you see that it's using a remote router DLC. Like here on router 2, if you saw frame map statements on router 2 that mentioned DLCIs 122 and 123, wrong right there, because all of your frame map statements on R2 at this point would have to refer to DLCI 221. Always map the local DLCI to the remote IP address. We're going to see some other details here. We're going to use iOS help on the live equipment to take care of that, look at the syntax and some options we might have, but that simple rule is the key to success with the frame relay map command. Now we're going to write some static frame maps, and what we're going to do is head over to the live equipment. I've got the addresses still on the routers, but everything else has been cleared off, all the frame that I put on there so we could look at the LMI. And when we start the next video, we will jump straight into the lab. I'll see you there.